So, Andy, I wanted to ask you about contact because it's something that comes up very often in practice, but we hardly teach. And I've seen, students kind of struggling with assemblies where they have contacts and they're getting convergence issues and so on. And in this particular model, you have done a very nice job of laying out, what the contacts are. You added in the contacts manually. Um, and then you decided, which is going to be bonded, which is going to be frictionless, which is going to be the contact surface, and which is going to be the target. So I wanted to get your perspective on what your thought process was as you, laid out those, those contacts.
Sure thing. And let me hop over to the model and I'll show you what I was thinking in the process. In this assembly, we have one bonded contact, which is between the bolt and the nut. When we do this in practice, if we were to fasten these together and we were to tug on the nut, it would be stuck in place pretty well with the bolt. Certainly, the bolt and nut is a more complex system where you have like a mechanical advantage system with a lot of threads. But we're looking, we can effectively simplify the model and get a very good answer. Now, admittedly, when I created my very first model, I bonded everything together to make sure that I could get results. And then I interpreted the results, and then I went further, and then I started adding in frictionless contacts. So when it comes to the contact between the two flanges, in reality, if we had strong hands, we could slide these two surfaces against each other, or we could pull on one and pull on the other, and they would be able to separate. So the bonded contact, if we use that, they would not be allowed to separate. In fact, they would be welded together. But in reality, they're not welded together. They're allowed to move and slide and separate, hence that condition. With the frictionless between the underside of the bolt and then the flange, one could do this bonded because there's enough friction to keep it in place. However, in reality, when one is putting on the bolt, there is a little bit of sliding here and there, so that's incorporated. In addition to the nut and the lower flange, there is some sliding allowed. And finally, between the shank or the threads and then the remainder of the hole, those surfaces would not be allowed to go through each other, but they're also not bonded to each other. So that was the logic in that. And I'll say in addition, you may be thinking, okay, frictionless is used here. How about not frictional? Because these parts they have some sort of friction factor. The friction factor is probably 1 because we have metal on metal. However, frictionless is nice because it takes the friction out of the equation. It makes one less thing for us to worry about, and it typically makes the results conservative. Meaning, if we're looking at gapping, it'll probably give us the worst case gapping. That's what I've seen in practice.
Okay, okay. Do you recommend that students start off with like bonded contact and to see that if that'll solve and then kind of go in and put in, frictionless and so on? Because bonded is, if that doesn't solve, then you have a real
Right.
problem, right?
Yeah, I think that's a great procedure, and it can save a lot of time just doing it progressively, adding in more complexity.
Yeah. I always keep telling students, crawl before you can walk. And
Yeah.
some take the advice, most of them are like, no, I want to get this done. And it's like, tell me which buttons to push to make it work. And one more thing I wanted to ask you about contact is, if you go to say, the first lower nozzle to mid nozzle, frictionless, say that one, how do you decide which is the contact and which is the target?
Oh, right. Okay, so the contact is typically the smaller body or the convex body in the case of rounded objects. And then in terms of the target, that's typically the larger body or the concave body. And that's what the user manual states. For many situations, it doesn't really matter which one you pick as target or contact. You could probably choose either. You could choose either in this case, and it won't make much of a difference because they're planar surfaces.
Mm-hmm.
And another way to figure it out is just to try both and then see if you get a difference in the answer. And I'll just add one more thing is that, so ANSYS calls it contact and target. And so contact has kind of like two meanings. We have the different contacts between the bodies, and then there's like the contact and target, which referred to side A and side B of the part. So just a differentiation there.
Yeah. And is looking for where these parts come into contact and how much.
Right.
Right. And typically you're putting contacts on surfaces, right? You're looking at where the parts come into contact with each other, and then you're picking those surfaces and putting in contacts there. Is that what you're doing? Is that your thought process?
That's correct.
That was very helpful, Andy. Thank you.
Okay, cool.